welcome to our December ethics webinar. We will give everybody just a few minutes to hop on this call, and while we're waiting, I just want to let you know we will take questions through your question panel. So if you're looking at your panel there that shows who's registered and who's online, you should see a section that shows questions. If you pull that down, you can type questions in there. You can do them as we go and as they come up, but we'll hold those to the end to make sure we get through the material that Liza and Amy have prepared for us today. And then we'll work through some questions. We always get some great questions. Welcome as many as you can think of. And we will be providing PDHs following this webinar. The way we do that is GoToWebinar captures those of you who are in attendance. And we reference that list of attendees, and we'll send out PDHs accordingly for those of you who were on the majority of that webinar. We'll also be asking polling questions today. So you'll be able to answer those on your screen, and we capture those as well. And then finally, we'll be watching some videos. Those do play through your computer screen, and you'll be able to hear them through your computer speakers. So if you have your computer on mute, you have to unmute your actual computer, not your phone, to hear those. So just to be respectful of everybody's time, let's go ahead and get started. So today we're talking about engineering ethics and liability, presented by Amy Connerton and Liza Kurtz. Amy Connerton is with Rinker Materials, and Liza is with Forterra. So Amy, I'll go ahead and turn it over to you.
Thank you, Kim. Good morning, good afternoon, depending on what part of the state you're in. Thank you for joining us. My name again is Amy Connerton with Rinker Materials. So today we're going to do a little bit of engineering ethics and liability. Our agenda is what are ethics? We're going to talk about industry code, and then Liza's going to launch into some pretty interesting case studies that we can go through. So what is the basic definition of ethics? It's the basic concept and fundamental principles of decent human conduct, essential equality of all men and women. A lot of words that you're going to be seeing today is health and safety, and also increasingly doing ethical things for the environment, for Mother Earth. So let's look at this as a big picture. Understanding ethics, codes of ethics are not law. Ethical behavior is not always protected by law. Companies in today's marketplace should realize that ethical behavior is an essential component to their long-term prosperity. An ethically made company usually helps its employees to face ethical conflicts, to allow employees to raise ethical concerns, and should explicitly prevent any retaliation for reporting unethical behavior. So make sure you work for a good ethical company. So Kim, would you want to launch these questions for us?
Yep, be happy to do it. So we talked about polls, so I'm going to launch this first one, and you can answer it on your screen. And how many states do you have a PE license? And you can pick one of those choices between 1 and 5 or more. Give everybody just a minute to fill that in. Okay, I'm going to close the poll. We have 80% who voted. And Amy, there's 54% who have their license in 1 state, 13% in 2, 9% in 3, 6% in 4, and interestingly enough, 18% in 5 or more states.
Wow, that's a lot of licenses to keep up.
Yeah.
And every state has different ethics requirements, so keeping that all straight is great. So there's another poll, Kim. You want to launch this one?
Yeah. All right. So the next one is how frequently does your continuing education requirement include ethics? So in other words, how often are you required to have an ethics class? Your state does not require any ethics. You have to get an ethics class, 1 PDH credit every 2 years. Do you have to do one every year or more often than once a year? Or perhaps you're not sure. Go ahead and select your answer there. All right, incoming responses have slowed down, so I'm going to close that. And Amy, so you're aware 8% don't have an ethics requirement. 29% have every 2 years. Most of our group, 52%, is every year. 3% is more often than once a year, and 8% are not sure.
That's a pretty interesting poll. So most of them are every year. Cool. All right, well, we're going to start out with some fundamental canons. We're going to focus on the National Society of Professional Engineers, which was formed in 1934, and it's dedicated to the non-technical concerns of licensed professional engineers across all disciplines, whether it be civil, electrical, structural, are all involved in the NSPE. So the NSPE has an engineering code of ethics with 3 different components. The first is the fundamental canons. Fundamental canons are general rules or principles by which something is judged. It's not the same as a law or a code, but it is a canon, the general rule. Along with the general rules or the fundamental canons are the rules of practice. These are used to clarify and specify in detail how you use the canons. And then thirdly, they have professional obligations, which is what are you supposed to do as an engineer when you're out there in the field. So these are the 6 fundamental canons through the National Society of Professional Engineers. One is to hold paramount safety, health, and welfare of the public. 2 is to serve services only in your area of competence. Number 3 is to issue public statements that are true and objective. Number 4 is to act for each employer or client as a faithful agent or trustee. Number 5, I think it goes without saying, avoid deceptive acts. And number 6 is to conduct yourself honorably, responsibly, and ethically and lawfully, and to enhance the honor and reputation of your profession. So let's get into the rules of practice a little bit with each one of these canons. Again, hold safety, health, and welfare paramount to the public. Such things that you have to look for is if you are doing a project and your professional judgment is overruled where you feel that the public is in danger, you have an obligation to report that to your client. Sometimes that's hard to do, but you do have that obligation. You do not want to engage or lend your name to fraudulent or dishonest persons or firms. You want to strive for principles of sustainable development, and you want to sign and seal only documents that you have done or reviewed. Number 2 is perform services only in areas of your competence. You do not want to undertake assignments where you're not qualified by experience or education. And you do not want to affix your signature to plans or documents where you do lack competence. Every state has different signing and sealing rules. I live in the state of Maryland. This is our seal, and this stamp about a professional certification must go on every page that is signed and sealed. And it's a statement that I am a duly licensed professional engineer. Now, an engineer may seal an entire project as long as the technical pages have been signed by the engineers who did them. To speak to this, I'd like to bring up this case that happened in the District of Columbia, our nation's capital. In 2014, a 5-story residence building was built directly over a DC water trunk sewer line. There was only about 2 feet of soil between the top of the sewer line, the masonry sewer, and the bottom basement of the building. The building foundation caused cracks in the sewer line. You can see it in the top here. No one notified DC Water about this building until it was done and ready to go online. Apparently, it had all been done by a structural engineer who signed and sealed all of the plans. When DC Water found the crack in the sewer line, they had to go in and do an expensive repair. What do you think happened to the building? DC Water made them tear it down because it was cracking the trunk sewer line. So having the capability and the capacity to do a project does have an effect. Number 3 is issue public statements only in an objective and truthful manner. Avoid material misrepresentation or omission of facts. Do not take credit for work that's performed by others, and be objective and truthful in reports, statements, and testimonies. So Kim, do you want to launch this question, please?
Yeah, so this first question, you're not going to be able to see
that's right.
the question.
I need to read
I'll
it.
Just read that.
Okay.
Yep.
Okay, so Engineer B wrote an article for a publication where he took a substantial amount of text from an article written by Engineer A that was published in another magazine. Engineer A, who had written the original article, contacted Engineer B about the word-by-word plagiarism of his text. Engineer B stated that he had submitted Engineer A as a reference, but the editor of that publication had omitted it when it was printed. So Engineer B had listed Engineer A as a reference, but it was not in the publication. Do you feel that Engineer B acted ethically?
Okay, so I'm going to launch that where you can actually answer. Did Engineer B act ethically in that situation? Okay, it looks like most people were able to answer that, so I'm going to close it and share the results. Amy, it looks like 24% said yes, he did act ethically. 58% said no, and 18% were not sure or said maybe.
Okay, it's a kind of a gray area, but the National Society for Professional Engineers did rule on this. They did say that Engineer A, who wrote the original article, did have proprietary interest in his article, and Engineer B should have asked for permission before using the word-by-word text of Engineer A. So it implies that Engineer B had done the work, which was not true. So that was that case study. So make sure that whatever you do is in an objective and truthful manner. Number 4 is act for each employer or client as a faithful agent or trustee. You should disclose any conflicts of interest you may have. You should not receive compensation from more than one party on a project unless it's fully disclosed. If you are in public service, You shall not participate in decisions with respects to services provided by you or your firm. So if you sit on a zoning board or a planning board, you cannot weigh in on projects that would affect. And you should not solicit from the government or contract where you serve as a public officer or official. Number 5, again, should go without saying, but avoid deceptive acts. Do not falsify qualifications, misrepresent yourself or your associate's qualifications. Do not offer, give, solicit, receive, directly or indirectly, any contribution that would influence an award of a contract. You want to launch the video, Kim?
Yes, I will do that. It'll take me just a quick minute to get that launched. Again, this will show through your computer. So if your speakers are not on, you'll have to turn your speakers on.
My name is Terry Niemeyer. I'm Chief Executive Officer and Chairman of the Board of KCI Technologies. I'm going to talk a little bit about the engineering ethics scandal that occurred in the 1970s with the Vice President of the United States. It took place over the late 1960s and early 1970s during the Nixon-Agnew administration of the presidency. My firm, KCI Technologies, was a predecessor firm of a firm called Matz Childs and Associates. They were headquartered in Towson, Maryland, and they were a firm working in the private sector, and they were having trouble getting work in the public sector. And they couldn't figure out why they weren't getting work in the public sector. And then one person whispers to another, and they found out that in order to get work in the public sector, you would have to kick back 5% of whatever your engineering fees were to an elected official and an official part of a county organization. And in doing so, they would get work, provided they would kick back 5% of their proceeds to this elected official. That elected official in Baltimore County happened to be our county executive, who becomes the vice president, who was Spiro Agnew. He was not the only one. There was a director of the State Roads Commission of Maryland who also was convicted of the same type of crime of income tax evasion. In addition, there were 7 engineers who agreed to be given immunity from criminal prosecution if they testified against them. And these 7 engineers, all from Baltimore County engineering firms, including the 2 principals of the firms that I now manage, agreed to testify against them. They lost their ability to practice engineering. They lost their engineering licenses. They were forced to lose their ownership interest in their firms. And at the time they were doing this, multiple engineers were doing this in Baltimore County. They weren't alone. There were a group, and again, I don't know the number. It's at least 7, could be closer to 15. But everybody, this was how you procured work in the public sector. And that's what they did. And so this cash flow would take time to produce, and then they would give money to their public officials. And if you recall, during those days, the county executive, Agnew, becomes the governor of the state of Maryland. And so these contracts that were going on when he was county executive also were there when he was governor. So they actually had to make payments to him when he was the governor of the state. And then lo and behold, when Richard Nixon slates him to be the vice president, they have to make payments to him as a vice president. When I did my research on this, it shocked me, as I said before. If I were the vice president of the United States and somebody called and said, hey, I have a bag full of money for you, and we're not talking great sums of money. So at the time, the dollars amounts were in the $5,000, $10,000 range. So it's not like they're a lot of something. I would have thought the vice president at the time would said, look, I know we did this before, but now I'm vice president. I really can't entertain this. But I do think the greed motive comes in and takes over. And again, I look at it that once you cross the line, it's so easy to continue to stay on that other side of the line that I felt that that's probably what these elected officials and high officials did. They were already a little bit dirty. and this was just making them dirtier. So well, they were already a little bit dirty. What the heck? And so I think they self-justified it in those ways. But I'm still shocked that something like that could happen at that level.
Okay, Kim. If you want to switch it back. Thanks. So again, I think it's kind of ironic that these people came forward because they felt what they were doing was wrong, but they still lost their licenses and their ability to, and their companies, and their ability to practice engineering, which was their livelihood, even though they came forward and everybody else was doing it. So again, like you see in the airports, if you see something, say something, and just because everybody else is doing it doesn't make it right. So, Kim, do you want to launch this question? This is kind of a poll, so I can find out how often this happens.
Okay, yep. So do the activities seen in that video that you just watched happen today with engineering firms paying to obtain government contracts? Yes, you know of some. No, you don't think it happens, or you're not sure. Okay, the answers have flowed, so I'm going to close that. And share with you, Amy, that 31% said yes, that it still does happen today. 21% said no, and 48% said not sure.
Okay. Well, it has happened in the state of Maryland in the past 5 years. I think it's kind of funny that Agnew did not go to jail on just taking kickbacks. He went to jail on tax evasion for not claiming that money on his taxes. There weren't enough ethics laws at that time to put him in jail for taking kickbacks, but there are nowadays. So. Now, the American Society of Civil Engineers has added 2 more fundamental canons. I'd like to just bring those up too. They have to continue professional development, to keep current in your field of specialty, and encourage others around you to attend meetings, present papers, and become registered engineers. So that's what you're doing today, is continue your professional development. And in July of 2017, they added an 8th canon. Engineers shall, in all matters related to their profession, treat all persons fairly and encourage equitable participation without regard to gender, gender identity, religion, age, sexual orientation, disability, political affiliation. You need to treat everybody the same in your profession. Your decision as an engineer does have consequences. If you affix your seal to a drawing or specification, you are legally responsible for that drawing or specification. If any product or material shown on a plan sheet sealed by you experiences a failure, you will most likely be required to defend your decision and determine why the failure occurred. So the last thing we all want to do is end up in court. So make your decisions with health, safety, and welfare in mind. So we're going to dig down just a little bit into some professional obligations. Just going to highlight a few. Again, honesty and integrity. You should always do things with the highest amount of integrity and honesty. If you believe that your client's project will not be successful, you need to tell them. You don't want to do outside jobs to the detriment of your employment. And you do not want to attract an engineer from another employer by falsification or misrepresenting the benefits. Engineers shall strive to serve the public interest. Again, you shall not sign and seal projects that are not within the standards where they are being built. You should participate in civic affairs and community, be part of your community, and adhere to sustainable principles. Sustainable principles are those where you fill the present need without taking from the future of our future people. Engineers shall avoid all conduct or practice that deceives. You shall avoid material misrepresentation of fact or omission of fact. And again, do not prepare articles and apply credit for work performed by others. Engineers shall not disclose confidential information without consent. If you work for one client, you should not tell another client anything about that client without written consent. So the business affairs of one client should remain in your information only. Engineers should not be influenced in their professional duties by conflicting interests. If an engineer, if a manufacturer or equipment supplier wants you to change your specification for a reason that you don't feel is correct, you shall not do that, even if they will give you free engineering or fees. So you as an engineer shall not accept any form of material or equipment supplier help for specifying their product. Engineers shall not obtain employment or advancement by criticizing others or improper methods. You don't want to criticize others to gain work. You shall not harm the professional reputation of another engineer. If you are in private practice, you will not review another engineer's project unless asked to do so and the engineer who did the original work knows about it, or the relationship with that original engineer is terminated. Engineers in government, industrial, or in education can review other work by other engineers when it is part of their duties. You shall accept personal responsibility for your professional activities. You shall not use others as a cloak. And again, give credit to those where credit is due. Recognize the proprietary interests of others. Engineers' design, data, records, notes are the employer's property. And a design for one client should not be duplicated without the permission of that client. So now I'm going to hand it over to Liza for case studies.
Liza, I think you're on mute. You just have to unmute yourself.
Can you hear me now?
Yep, we can hear you.
Okay, great. Amy, thank you for your introduction, and to all of the ethical rules and guidelines and canons provided by the National Society of Professional Engineers as well as ASCE. They're always very informative. And now we're going to actually look at some case studies that involve a couple of different engineers and projects that have had some difficulties and eventually led to court cases. So these are actual court cases, so we know what the outcome is at the end of the trials, but wanted to bring this to everyone's attention. So let's go into our first case study, I think. There we go. And as we evaluate these different case studies, one of the things that we're going to be concerned with is liability. And here are some definitions of liability. The one we're most interested in today is the last one, which is the condition of being responsible for a possible or actual loss, penalty, expense, or burden. So we're going to be looking for liability and who is responsible for this. And as engineers, how we play our part in each of these type of scenarios. So our first one, oops, I need to hand this back over to Kim for the video.
Okay, give me one quick second. And then Amy and Liza, if you guys will mute, that way we don't hear it through your phone. Again, this will play through your computer, so you have to turn your speakers on.
We have been helped out by some digital surveillance video, though, that was taken from the Lock and Dam, the Army Corps of Engineers, releasing this video to the media today, as well as the authorities with the NTSB. They have used it to try and determine what happened. Mayor R.T. Ryback has told us that they were hoping to see more from this video. They were able to see some things that they had their doubts about, some things that may have answered some questions, but not as much as they had hoped to see. But this is just a piece of the puzzle that they'll be going over in the next several days, weeks, and perhaps months ahead. But it will help speed up the investigation process.
Otherwise, I think you'll have to unmute again.
It takes it just a minute to unmute.
Yep, we can hear you.
All right. Were y'all able to see the entire video?
Yes, I did see it.
Okay, because it blipped on my computer, so I wanted to make sure. So we've learned a lot about this 35 bridge collapse in Minnesota, and this happened in early August. And there was a lot of devastation because there were a lot of people's lives that were harmed. I mean, look at the different vehicles that are existing on this bridge. Several people were missing for several days. So this was a huge outcry from the public about a disaster that happened that obviously has some engineers related and involved. So in further inspection, they went back to the original bridge design and determined that, first of all, this collapse occurred on August 1st. They did determine that it killed 13 people and it injured 145, which is significant. The original design and construction was performed in 1964. So this happened in 2007, many years later, and probably the original design engineers may be around, they may not be. But they wanted to know what caused this. Why did this happen? I mean, there were lots of different images that we saw. I know I remember hearing about it. It just incredibly impacted the engineering community as a whole. And it brought into question our nation's infrastructure and really supported a lot of what's going on with the ASCE report card, where we're talking about how our infrastructure is failing or across the country, and it's all aspects. But this really called into question the bridges. Here are some different viewpoints of the bridge as it collapsed. And again, you see those vehicles that are stuck or crushed underneath the bridge as it collapsed. So everybody wanted to know what went wrong. They hired forensic investigators to come out to determine what the cause was, and they evaluated the different pieces that are integral to this particular bridge. They did determine that the gusset plates were too thin and undersized to be capable of supporting the loads. And so here you see some of the deterioration and damage at the gusset plates as they failed. So when they called the gusset plate into question, they were looking and redoing a lot of the design calculations and figuring out where the fractures and flaws were in the design and how they could have possibly be prevented. And so here we have a detailed drawing showing where they're having some of the different fracture areas and that ultimately caused the failure of this particular bridge. Here's another 3D rendering showing you that same fracture and how it just starts to shear and tear and pull everything apart. The DOT had been conducting inspections of this bridge on a regular annual basis. And in 2003, this is what one of those inspections noticed. You can see that there's a deviation in that gusset plate. It's already starting to bend and so it loses its integrity. So it's already starting to head toward that fracture. And when they started to notice this, they hired URS as a company to evaluate and perform a structural analysis and failure analysis on the different parts. And so they were joining the DOT as they were going out into doing these inspections. So we went back to the original design, and they were the ones who put together the original gusset plates, and this was in 1964. Jacobs is the engineer now. They had acquired the company that was the engineer in 1964 that did the original designs. And then, as I mentioned, in 2003, URS was hired to do a fatigue analysis on all of the structures. And as they were partnered with the DOT in doing the inspections, one of the things that URS determined is they did not need to perform an analysis on the gusset plates because the original designs they thought were capable and sufficient at the time. So URS did not actually perform fatigue analysis on those particular gusset plates that ended up failing in the end. Another factor in the criteria is that there was a maintenance contract being let on that particular bridge at the time, and during the construction of the maintenance, they were leaving some of their heavy equipment on another deck. So there's an additional loading factor that was not taken into consideration at the time. So all of these different aspects led to the failure of this bridge. First of all, it's an older design. They were designing for lighter loadings of the structure initially. And then when they were doing the fatigue analysis, they decided that the company that was performing the fatigue analysis determined that they would not analyze the gusset plates relying on the original design, and also additional weight provided by the maintenance contractor. So this whole case went to the court system and was being tried. They hired the forensic analysis to determine all of the different causes of failure. And that leads us to the question that we have for you here today. Who would you find as the engineer that you are, who would you find financially responsible for this failure? Would it be the design engineer, the original construction contractor in 1964, the fatigue analysis engineer, or the repair contractor doing the program, the construction on the bridge at the time? And I will hand this back over to Kim to conduct the poll.
Okay, thanks, Liz. I launched that poll, and just so you guys know, you can't select more than one if you think more than one would be responsible in this case. Okay, the answers have slowed down. I'm going to close that and share those results with you, Liza. So 53% of the group that answered said the design engineer, 12% said the original construction contractor, 82% said the fatigue analysis engineer, and 41% said the repair contractor.
Well, that's actually a very interesting analysis, and that pretty much comes into play with what the actual courts determined. So this is another picture of that horrible tragedy, and the final outcome that was determined after several lawsuits and whatnot. Jacobs ended up paying almost $9 million in the settlement, but they did not admit to any wrongdoing because they were not the original engineer. Even though they had acquired that company, they did not feel that they as a company did anything wrong. However, they wanted to expedite the settlement process, and so they agreed to pay $8.9 million. And URS paid $52.4 million to resolve the issue as well. And they had no admission of liability or fault. so that is what the final outcome was to be. The contractor that was performing the maintenance, they actually did have another, it was a smaller amount that they paid. I don't remember the exact numbers, but that was considerably less than both Jacobs and URS. There was no fault found with the original contractor because it went back to the original design not being sufficient. And so where this comes into play for us as engineers moving forward, when the original design engineer was designing, they were not necessarily performing their engineering duties to consider the public safety and welfare, as Amy was talking about throughout her portion of the presentation. And same thing with URS, when they were doing the fatigue analysis and they were unable to, or they chose not to evaluate the gusset plates. In that, they were, again, not holding the public's health, safety, and welfare as their number one priority. So that is our ethical obligation as engineers, is to hold the public safety paramount to every one of our single designs. So that is one case study, and that will lead us to our next case study. This is a fish hatchery that was being built and designed, or it was being built in Jasper, Texas, and the engineer was hired to design and install drainage for all of these different fish ponds, and where they were going to be raising different types of fish to populate all of the parks and wildlife lakes throughout the state of Texas. This project was valued at $27 million. And the project began construction in July 2008, and they determined that they wanted to use a flexible pipe material. They were using a significant amount of piping between all of these different fish hatchery beds because each one of the beds needs to be drained of water and filled with water at different times as they are raising different populations of different fish. So they had 11,000 linear feet of HDPE pipe ranging in size from 30 inches up to 60 inches. So that's kind of where the project started. And it's a significant project for the Texas Parks and Wildlife. It was going to bring lots of fish populations that they've not had available to the different parks in the area all over Texas. As they were going along in their construction, in April of 2009, they determined that several of the pipes had collapsed. And there were deflections in all of the different pipe sizes of HDPE, anywhere from 30 inches up to 60 inches. And at that point, the project was only 30% complete. So when this collapse happened, they determined that they would have to file or hire a forensic investigator to come out and evaluate all of the property, all of the product that was being installed, and determine what the true problem was with this project. And the outcome of that report was determined to be excessive deflection. So here is a little bit more detail about where the failures happened within the fish hatchery project. The first one was in the design phase. They determined that the engineer incorrectly used the design chart that was provided by the manufacturer and did not take into consideration the effect of groundwater. They also did not provide adequate construction phase services such as site visits, reviews of compaction tests, and records. They also did not take advantage of the available geotechnical reports and didn't take into proper consideration the in situ soils being used in consideration for proper pipe design. And finally, they specified the improper backfill and compaction materials for this particular pipe installation and project. So that's what the analysis determined for the design failures. Now let's move on. We have the installation failures. So during the installation phase, there was not sufficient compaction. They didn't utilize the trench blocks properly, as in it was too narrow. They could not get adequate compaction equipment on either side of the pipe within that trench, so they were not able to support the pipe as it should be, as it is described. And so they were not able to provide sufficient compaction. And as they were continuing their construction, they were dragging the trench box along the trench, thus disturbing any compaction that they had achieved. Because as you drag a solid surface through the soil, it's going to leave a gap and an opening at the very edge. So the ideal trench safety would be to lift your trench box, move it to the next location, and install it, not drag it through the trench. They also did not de-water underneath the pipe in the trench. And they didn't use the correct RFI, request for information process, to resolve any discrepancies between the soils and the compaction that they were achieving. So these were some of the different installation failures that were noted in the forensic report. So during the inspection criteria, here are some options that the inspectors could have been looking for flexible pipe materials. They have wall crushing, reverse deflection, localized buckling, and over deflection. In the real world, instead of just on pen and paper, these are some images of what those types of inspection could be looking for. So if you have wall crushing where you've got the crinkling of the pipe, if you have the reverse deflection where it folds in on itself, or if you have a localized object that has pushed its way into a portion of the pipe, or if you have over deflection or ovaling of the pipe. These are different inspection criteria that they could have used on this project that was utilizing flexible pipe. If you are interested in learning more about the different inspection criteria or for concrete pipe, we have a pre-installation and inspection presentation that was given in October that refers to AASHTO R73 and gives you all of the guidelines of what you could look for in concrete pipe. So that's my commercial for our previous webinar. You can go find that recording on the concretepipe.org website, and you can review that if you have any questions. And I'm also going to give a plug for our future webinar, which is on post-installation inspection and will be given in February. So that one we don't have available on our website yet, but we will at the end of February, and there will be more information about that to come. But back to our Jasper Fish Hatchery. We had an article that was written up in Outdoor News, and they were still trying to determine who was at fault. Was it the engineer? Was it the contractor? Who was going to be at fault? And so in the interview, the Texas Parks and Wildlife Director, actually, I love this, you can appreciate the location. Both the construction, the director stated that both the construction company that installed the pipe and the engineering company that designed the project are saying they did everything right. But it is real obvious something went bad wrong here. And unfortunately, that is the truth. Something did go very wrong. And so we now need to determine who is to blame. And so at this point, we have another polling question, which I will turn over to Kim. We get to determine who is responsible for this project. And you can select more than one option, whether it's the manufacturer, the design engineer, the contractor, or the public agency.
Okay, and that's launch sizes, so I'll let everybody a few minutes to answer. Okay, let me close that one. I'll share it with you. So Liza, 21% said the pipe manufacturer, 91% said the design engineer, 89% said the contractor, and 17% said the public agency or owner.
That's very interesting. I actually enjoy this particular case study because it's always interesting to see, as engineers, how we would assign who is liable and who is responsible for this. And quite often, it's a very mixed bag. So it's interesting to see that we've got majority for both the design engineer as well as the contractor. Some are even blaming the owner, and then there's another small amount that's blaming the manufacturer. So in the real court case, this is what the outcome was. When you assign liability, they determined that there was a $3.3 million cost for this particular failure. The total project was $27 million, and so to move forward, they charged, or they were, I guess it was a $3.3 million lawsuit. And from that, the design engineer was actually held almost entirely accountable. And they paid $3.18 million to the owner. Then they paid an additional $213,000 to the contractor. So all of this was paid by the design engineer. The contractor didn't pay anything, the manufacturer didn't pay anything, and the owner. All three of those entities were not determined to be at fault in this particular failure. It went back to the design engineer. And you saw as we went through the list of the different design failures as well as the different installation failures. So it's very interesting. And then the cost for the Texas Parks and Wildlife Department, who is the owner in this particular case, was a total of $140,000 and 1 year of downtime on their part before they could get the fish hatchery back up and running, and the project delays due to the lawsuit and failure. When they did go back to finish and complete this project, the HDPE pipe was replaced with reinforced concrete pipe as well as PVC, depending on the different diameters. They needed to have something with a little more strength and rigidity. And so these were the pipes that they chose. And the total project delay for this particular failure and lawsuit was 2 years, and there was considerable negative publicity. So all of these we need to take into consideration when we are engineers and we are doing our design. Now, to do a comparison for designing between concrete pipe and flexible pipe, when an engineer specifies concrete pipe, they say that it must be manufactured according to ASTM C76 and installed per ASTM 1479. At which point the project bids, the manufacturer gets a hold of the bid tab and takes into consideration, okay, we need to build pipe according to C76. Okay, got it. We have our design parameters. We know what we need to do. The contractor or installer says, okay, we're going to install everything according to ASTM C1479. Okay, got it. We've got our guidelines. We know what to do. In the case of flexible pipe, the engineer will put on their design drawings as per the manufacturer's recommendations. All good. The manufacturer says to be installed per ASTM D2321. Then you get to ASTM D2321, and this standard states that the engineer is responsible for numerous aspects of the design and installation for this particular pipe material to be success. And it's referred to 29 separate times, and so, whoops, I went the wrong direction. The responsibility ends up back on the engineer. And so for this particular fish hatchery case, where the engineer was found entirely at fault, this is the reason why. They go back to the standards and say, how is this supposed to be installed? Did the engineer follow all the different guidelines and requirements as put into the ASTM standards, the city specifications, the county specifications? Do all of them match up who is responsible for what portions. And in the case of the fish hatcheries, the engineer did not succeed in following all of the different guidelines as set up through the ASTM standards, and therefore was found at fault paying the full amount. So it's not that we as engineers should use one pipe material or another. We need to be aware of what our guidelines are, what our specifications state, and what our responsibility is. In this case, there were no lives lost. The public's health, safety, and welfare was not held in disregard. In this case, it was just an oversight on the engineer's part and needs to be something that we take into consideration with any material that we're using, whether it's the gusset plates for doing the inspection, whether you name it. So all aspects of this are what engineers need to take into consideration when they are performing their honest and ethical works. If you'd like to know more about this particular project and situation, there is a publication offered through the American Concrete Pipe Association. They have a public works article that was written, and we have that available for you through our website. And that concludes our engineering and ethics presentation today, put on by Amy Connerton with Rinker Materials and myself. You have our phone numbers at the bottom, and if there are any questions, I guess we can hand that over to Kim.
Yeah, great. Thanks, Liza. Appreciate that. Just a couple, we did get a couple of questions, and while we're working through those, just as a reminder, if you do have questions that you've thought of, if you'll just open your question panel or the section of your panel where it says questions, you can type those in there and send them over to us, and we'll get them covered. So the first one we had, Liza, this one's back to the Minnesota bridge failure. They wanted to know, why wasn't MnDOT included in the fault? Good question.
That is a very good question. And I don't have the exact answer for you with why MnDOT was not held accountable, other than because URS was the one doing the inspection to determine the fatigue analysis, and they were contracted with MnDOT to do that fatigue analysis. MnDOT was purely doing the inspections. They weren't necessarily doing the repairs based on the inspections. They were hiring outside sources to do repairs.
Yeah, that's a great point. And as consulting engineers or design engineers that may work for a public entity, it's key to keep in mind that a lot of times those state officials are indemnified against a lot of liability. And that liability will fall back on the consulting engineer that they have hired to do the work. Another good question, this one's also to you, Liza, for the fish hatchery case study. How was the contractor not partially responsible? Did the designer not specify any kind of compaction?
I'm sorry, could you repeat that question?
They were wondering,
contractor wasn't found responsible?
Yeah, how come the contractor didn't take any responsibility, or at least partial responsibility?
In the lawsuit for the fish hatchery case, all of the evidence referred back to the original design plan. And while the contractor was supposed to be installing per certain guidelines, they are still supposed to be overseen by the engineer. And so ultimately, it's the engineer's responsibility in that case to oversee what the contractor is doing with the installation. And so by proxy, that alleviates some of the risk and liability that the contractor had in that case.
Yeah, I think that's a great point, Liza. And I think what you had stated before is also a good point, that that D2321 does point back to the engineer 29 times. So as engineers, we need to make sure we understand what that specification says and not just say that that's an installation spec and the contractor has to follow it. But as engineers, we have to understand what our responsibility and liability is within that specification. Okay, another good question. Actually, this one's kind of more of a point. Liza, your pictures you had up there of some of the problems that were found in the plastic pipe. Somebody just pointed out that it seemed like a bad idea to crawl through a partially collapsed pipe. Isn't that why inspection cameras exist? So they were just making a good point that there are ways to inspect without having people crawl through those pipes. I don't know if you.
I would prefer that. I would certainly prefer to have cameras go through that. I personally would not want to. There are also confined space training, because that is most certainly a confined space. So we don't know all of the parameters of what was going on in that particular situation. However, for my own personal preference, I would much rather send a camera down that pipeline than send myself. So I concur.
Okay, this is kind of a logistical question on this webinar. Somebody just said do we have the recording available? Yes, the recording for this webinar will be available. So it'll probably take us a few days to get that up on our website, but you'll get a link following this webinar. And then maybe next week or after Christmas, you should be able to find that webinar and the PDF of the presentation. Okay, another good question. Let's see. So the design engineer was also responsible for the construction inspection. This is going back to the fish hatchery example, when he was asking about how did the contractor was not held responsible.
So the question was, the design engineer was not held responsible, or the contractor?
His question, his original question was, how was the contractor not held responsible? His follow-up question is, the design engineer was also responsible for construction inspection. That's his question.
That is correct.
Is that true?
That is correct. And part of that comes through ASTM D2321 for the installation of flexible pipe materials. It states that the design engineer is responsible for certain aspects of inspection during the installation process.
Okay, there's another good point. I think this is more of a statement rather than a question. I want to bring it to attention that there may be more than one engineer on a project. For example, in this case study, there's a materials testing engineer, a geotech engineer, and a design engineer. It's important that the design engineer ensure that the client employee oversee all responsibilities. Okay, go ahead, Liza, if you had a follow-up on that.
Oh, no. I'm good, thank you.
Okay, another logistical question was asked on how you guys will receive a certificate for participating in this. So again, this will take us a couple days to get out, so sometime next week you will get an email. We check our attendance roster that GoToWebinar captures for us for you guys participating. Once we've confirmed your attendance, we send out that PDH through email, and you'll see that from Wanda Cochran, who's our administrative assistant. So she'll send those out probably next week. All right, another question is, isn't it a conflict when the designer does the inspection?
A conflict of interest for the designer to do the inspection? Is that the question?
That's the question.
Okay. For it to be a conflict of interest, in that particular case, I don't believe that it is a conflict of interest. I know in my previous life as a consultant engineer, we often would design a project, we would go out to the field, and we would inspect how it's being installed, making sure that it was being installed properly, because the end client is the one who has to live with the result one way or another. And again, just like in the fish hatchery case study, it would come back to the engineer's responsibility if there is a failure of whatever material is in the construction phase. So I think it's the engineer's responsibility, no matter what your material is, to actually go out there and do the inspections, make sure they're being installed properly. Because guess what? That's you. That's your license. That's your responsibility.
As long as it's disclosed to all parties that you will also be doing the inspection, which is usually under a separate contract, that is not a conflict of interest, as long as it's all disclosed.
Okay, another question. These are great questions. Ran off the screen there. For the pipe failure, was the material tested and ruled out that it was built to specification?
To that question, there is more information about that, all the findings in that particular court case that are made available to the public. So you can do some more research with that and find out more about this particular case regarding whether or not the pipe material was tested to determine whether it was at fault or not.
Okay, great. Another question is, how does the ASTM requirement apply if the client does not want to include inspection in the contract because they have an internal inspection crew?
How does the ASTM for inspection apply to the contractor?
Yeah, how does it, I'm guessing he's talking about D2321. How does that requirement that places that liability on the engineer, how does it apply if the client doesn't want to pay the consultant to perform those inspections because they want to use their own crew?
So the client wants to use their own inspection company.
Right, and not pay for inspection for the consultant.
That comes down to the ASTM standards, and that is one of the guidelines. If that is included in your design specifications and for the project, then that is the governing entity. It is a national standard. It is not a local standard, and any lawyer will review that national standard and hold the parties responsible. If the client does not want to utilize that, it's still going to be up to the original design engineer to do those inspections on their own, whether they're paid or not, because again, it's going to come back to their license. The owner is welcome to hire their own, but it still boils down to the engineer's responsibility. These are legal documents.
Yeah, great point. Another good question. Are civil consultants responsible if they are not engaged to provide this CA work? I'm thinking it's QA work.
I'm sorry, could you repeat that? My phone glitched, or I couldn't understand the last half.
They were wondering if the civil consultant is responsible if they're not engaged, I'm guessing he means or hired, to provide the QA. Oh, construction admin. He did mean CA.
Okay, construction admin. If they are not hired, it is still going to be their license that is on the line. And like I say, anytime you have a design specification and plan detail drawing that refers to this ASTM standard, that is a legal contract document. If the contractor or the owner choose to disregard certain aspects, it is still going to become, in a lawsuit, in the case of a lawsuit, it is still going to come back to that design engineer. So whether they are hired and paid to do the construction administration, or if it's duplicated, then it's still going to, anytime there is a potential for a lawsuit, it will come back to, did the engineer comply with ASTM D2321? So it's still the ultimate design engineer's responsibility.
Okay, great. Thanks, Liza. Thanks, Amy. I think we have the last couple announcements before we end the webinar. There's something
yes, do you want me
coming
to
up we wanted you to know about. Yeah, go ahead, Liza.
All right, those are still on my presentation. We have an upcoming save the date. The ACPA is holding their 2020 Pipe School and Pipe Show at the Embassy Suites in San Marcos, Texas, January 6th through 9th. And you are still able to register and come participate in another opportunity for continuing education. And speaking of another opportunity for continuing education, we have our next webinar that will be on post-installation inspection on February 20th, 2020. And that was what I alluded to earlier in my presentation. So we hope that you will be able to participate in these events and look forward to seeing you there.
Yeah, thanks, Liza. I'll probably send out the invitation or registration link for this February webinar after the holidays. So just keep an eye out for that. And then on the Pipe School, if you have interest in attending and you need financial scholarship assistance, if you want to give me an email, we can work to see if we have any funding available for you. But we would love to have everybody join us if you're available in January. So thanks so much for joining us today, and we hope to see everybody back in February. Again, PDHs and the webinar link will be available probably by next week. So thanks again. Have a great day.
Thank you, Kim, for your help.
Thank you. Have a great day.